go, that's saved. Okay, so here we go, 2.2. 2x equals 14. There's the wall. X is saying what he's always saying, I want to be alone. Now, you guys know what to do, but you tell me, what if I said, and you know this isn't right, subtract 2 from both sides. Why is that not right? Yeah, because the 2 is what? What's the relationship originally between the 2 and the x? Multiply. And so what's the opposite of multiply? Divide. Yeah, so we have to divide by 2, not subtract 2, right? We all good with that? If it was 2 plus x is 14, then yeah, then we would subtract 2, and we would get x is 12. But if it's multiplied, right, and it's 2 times x, that's the original actual question. 2 times x, you got to divide by 2 on both sides, right? That's what we need to do. X is 7. So we divide in this case instead of subtract. We always do the opposite of whatever's happening with x. So if it's times next to x, we divide. If it's added next to x, we subtract, right? We always do the opposite. Yeah? Yeah, you're right. We'll get to those. Those are a little more advanced, but you're right. You are right. What's that?
Wouldn't you divide the x and not multiply it?
Divide the negative 1? You can actually do either one. Multiplying or divided by negative 1 has the same effect. Okay, so 12 equals 6x. Here's the wall. X is saying, I want to be alone, so try that one. What do we do to get x alone? Divide both sides by 6. Boom. And that's just 2 and we're done. Just like that, right? All right, these are easy ones. All right, so negative x is 43. So there's the, well, it's a messy equal sign now. So there's the equal sign, there's the wall. X wants to be alone, and that means not even a minus sign in front of it. We're not allowed to leave anything in front of it. How do we get rid of that minus sign? What are we going to do here? Yeah, it's because really it's an invisible, right? Remember they're always there? They're hiding out, the invisible ones all the time. So there's really a negative 1 right there, isn't there? So how do you get rid of that negative 1? You divide both sides by the negative 1. Or technically, you could multiply it. That's what I was meaning. It would work the same either way. For 1, it wouldn't work for other numbers the same way. But it does for a 1, because 1, multiplying, dividing, same thing. So anyway, I'm just going to divide by negative 1 both sides. Why does that work? Well, you tell me about the left side. How many negative signs? Now. 2. And what is 2 minuses? Positive x, or just regular. You don't need to show the plus sign. Regular x, huh? The other side, how many negatives on the other side? 1, so it's negative 43. Does that make sense? So you just divide both sides by negative 1. That gets rid of the negative. That x has got his wish. He's alone, meaning not even a sign in front of him, or plus really. Nothing is with him. He's completely alone. And so really it just changed the sign of the answer, didn't it? And if you wanted to save time, you could do it. If you get down to like negative x is 43, you can just go, okay, that just means x is negative 43. You're right. It's just going to change the sign. That's what it'll do every time. Good on that? I think you'll know, but we'll do it anyway. So negative x is negative 35. Give that a try. X saying I want to be alone. So what do we do to get x alone? Both sides by negative 1, right? And then 2 negatives, positive 5. So you could have just changed the sign on the right side from the beginning. Same effect, right? When you get to negative x is negative 35, you want to say, oh, it just switches the sign. So it'll be positive 35. You're right. That's what it does. Getting rid of the negative by the x just switches the sign on the other side as well, because you divide both sides by negative 1. And 2 negatives become positive. All right, you got it. Okay. X over 4 is negative 8. All right, so try that one. X is over here, saying I want to be alone. Get rid of this 4. Remember, do the opposite. Always do the opposite. So let me give you a second on that one. What's the opposite of dividing by 4? Multiplying by regular 4. Right, the opposite of dividing is multiplying, huh? So the opposite of dividing by 4 is multiplying. You got to do both sides, right? Because you got to do equal treatment. They were equal before, treat them the same, still be equal. Right, so multiply both sides by 4. This is really, remember, whole numbers are really over 1, cross cancels by 4. That's why that works, huh? To get x alone. Other side, just multiply them, negative 32, done. X is alone. Is that good? Okay. Is that the real answer? Like from the beginning, if x had been negative 32, would that make it true? Negative 32 divided by 4? Yeah, is negative 8, huh? We're finding the value that makes it true. That's what we're doing. By undoing what's next to x to get him alone, right? It's the pattern of this book. Okay, so 3/13 x is 18. Here's the wall. X is 10, I want to be alone. So what am I going to do now? I got to get rid of that entire fraction now. The whole 3/13. I'd like to get rid of that whole thing in one fell swoop. How do I do it?
Maybe you can multiply 13 over 1.
Do what's that, 13 over 1?
Yeah, and then you would be left with 3, and then you could divide 3 by both sides.
You totally could. That would work great. I would like to put those together and do them all in one step.
Oh, so you could literally just do the reverse.
Exactly, exactly. Yeah, just whenever you got a whole fraction next to x, you want to get x alone, just multiply by the upside down. Just put the 13 on the top and the 3 on the bottom. I mean, you could do it in 2 steps, but why don't we just do it in one? And whatever we do to one side, we have no choice but do the same thing to the other. Good, good. And then the 13s cancel and the 3s cancel, and x has got his wish, he's alone. Now, how about the other side? What do we always do when a whole number like 18 is interacting with a fraction? Put it over 1, make it look like a fraction, then cross cancel, and whatever's left over multiplies, right? Question? Good? Making sense? So 3 goes into 18 6 times. Make sure you're clear, those are gone. Cross those out big and bold. Don't skip that. That'll help you. 3 and 18 are gone. 6 remains, and of course 13 hasn't gone anywhere. 6 and 13 both remain. What is 6 times 13? 78, right? That's our answer. See what happened there? Is that good? Questions on that one? All right. So, minus 2/7 x is 8/3. Here's x, x and 1 below. So give that a try. Do something to both sides, one step, to get rid of all that stuff. The 2, the 7, the negative sign, everything. Get it all out of there in one step. Going to multiply both sides by the upside down, right? Are we going to multiply by negative 7/2 or positive 7/2? Negative. Because we want the 2 negatives to make positive. So x will be totally alone, right? Does that make sense? So multiply both sides by negative 7/2. Like that. That's multiplying both sides, right? Parentheses. So 7 cancels 7, 2 cancels 2. And the two minuses make plus, and so it's just regular x, huh? We got rid of everything. See how you needed minus? See, if I just made a regular 7/2, do you see how that would not have worked? Because then I would have just had one minus, and it would have been minus x, wouldn't it? X would not have been alone. I mean, I could have done one more step to get rid of that minus, divide both sides by -1. But I'm just saying, if you want to do it all in one quick step, multiply both sides by -7/2, because the two negatives will make positive, and x is completely alone in one step. All right, so now what happens on the other side? 2 goes into 8, cross those out real clear, 4 times. 7 goes into 35, 5 times. Huh? Use calculator if you're rusty on some of those. And we have a minus left over. So all we have is minus 4/5. Is that good? Questions I can answer. All's well? Okay? All right. Okay. So minus 8/13 x minus 40.8. Okay. All right, same thing. You know, whenever there's decimals, like on this one, I would definitely use a calculator. It just makes it easier. Just use your calculator with decimals. So same thing, you're going to multiply by the upside down, right? Multiply by the upside down. But when you do, to actually figure it out, I would use my calculator. Maybe I should just show you what I mean. So you know the first step. Here's the wall. Multiply by the upside down. Minus 13/8. Minus 13/8. Both sides. Good. And then we start canceling stuff out. 13s cancel. 8s cancel. 2 minuses make plus. So that got x alone. That's why we do it. Now, how do you do the other side? Well, first off, what's the sign going to be on the other side? Positive or negative? 2 minuses? Positive. Good. Now, how do you actually get the answer with your calculator? Well, I would just take 40.8 times 13 divided by 8. You multiply the top number, divide the bottom, because that's what a fraction means, huh? The denominator is divided by, right? So I would type it in just like that. 40.8 times 13 divided by 8. Is it 66.3? Is that right? It is 66.3. And that's our answer. Is that good? We good with that? Questions on that one? Questions? You all good? So again, decimals. So I'll just say decimals. Use your calculator. If you have decimals, just use your calculator. All right. Together. Put this stuff we've been doing in the last two sections together. So 6x plus 10 equals 40. There's the wall. So x is saying, I want to be alone. So what do we do to get x alone? Yeah.
I just have a question. Would you follow the PEMDAS or whatever in this when you're doing this? So would you do the multiplication and then do the subtraction?
Really good question. I like that. I like the way you're thinking. I normally bring that up and nobody thinks of it. Good. Really good question. Yeah, so what I'm going to suggest, this is my suggestion, is you do your adding, subtracting first, and you divide by the identical twin last. Now, it sounds like, go ahead and write that down. So first do your adding, subtracting, second do your dividing. Sounds like I'm breaking the PEMDAS rule there, doesn't it? I thought adding, subtracting had to be last.
Is that the same thing for multiplication?
What's that?
Is that the same thing for multiplication? Before you're not dividing, you're multiplying?
No, it's because we have an equation. So I'll talk with you. Go ahead and write that down, and I'll explain. It's because we have an equation here, so I don't have to follow PEMDAS. PEMDAS, please excuse Madeira and Sally, order of operations, all that, that's for when you don't have an equal sign. Just think with me logically for a minute, rather than me just, to me, math would be so boring if it was just rule after rule after rule after rule, and you just follow them rules, right? And maybe that's how you feel. Maybe that is how you feel. But it's not. It's logic. It makes sense. So let me help it make sense for you. Remember, I have an equation up there. I have a left side and a right side. They're equal. So I can do whatever in the world I want, whenever I want it, in whatever order I want it, as long as I do it to both sides, right? Isn't that reasonable and true? If two things are equal and you treat them the same, they'll be equal when you're done, right? Isn't that true? It's not somebody's rule, right? You don't want to do math like Mr. Heron said so, or this math book said. You want to do what's true. What's true. That's what I enjoy about math. It's just if you follow what's true, you're good. Doesn't matter about your style, or if you followed the I before E except after C. Unless it's a rainy Tuesday, then you just do whatever, right? None of that. Just logic, 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 logic. Truth, 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 right? So isn't it true that if two things are equal, you could, as long as you treat them the same, they got to be equal afterwards. They can't not. So that's why I say PEMDAS doesn't matter for an equation. PEMDAS, if you look back, was for things like 2 plus 3 times 4, right? That's not an equation. That's not a left side and a right side. That's just an expression, we call it. And the only way to work that out, you must multiply first. 14. You can't add first. 2 and 3 would be 5 times 4 would be 20. That'd be the wrong answer. Why? Well, because there's not two sides there. You can't just, they're not two things that are equal and you're doing the same thing to both sides. That's just operations, and you got to put them in the right order, right? But with an equation, when you have an equal sign, you have freedom. You can do whatever you want in whatever order you want, as long as you do the same thing to both sides, they'll still be equal. So that's why I can just throw out the PEMDAS rules and do whatever I want. So, and that's why also I say suggestion, because you don't have to do it in this order. You can do it whatever order you want. This is by far, well, I don't know why that went out, about 99% of the time, the easiest. So that's the order I'll follow. Yeah?
But doesn't it change the answer if you were to divide first and then subtract?
No. Let me show though. But remember when you divide all three.
Oh, okay.
That's the trick. So anyway, let me do it the easy way first. So adding, subtracting first. So what's X saying? X is saying I want to be alone. So what do we do to get, what's our first step to get X alone? Subtract that 10, huh? And I want you to notice when we add, because you might wonder what I mean by this identical twin thing. Notice when we add, subtract, we always add, subtract the opposite sign, don't we? But when we divide, we will divide by the same sign. So I want to be real clear so you don't get mixed up on that. That's what I mean by identical twin, same sign, for dividing. But adding, subtracting is always opposite, right? So when I add, subtract, it's plus 10, I do minus 10. If that was minus 10, I'd do plus 10, wouldn't I? I always do the opposite sign when I add, subtract. This goes away, and then I get 6x equals, what's that, 30? Good so far? And now last step, X is saying I want to be alone. So what do? Divide by the 6. But notice, I don't divide by negative 6, do I? I don't do the opposite sign when I'm dividing. I do the same sign, don't I? Why? What if I did minus 6? Well, the 6's would cancel, and there'd still be a minus sign there. That wouldn't be good. X wants to be alone. That wouldn't put X alone. So do you see what I'm saying? Whenever you divide by the identical twin. Same sign, in other words, not the opposite sign. Whereas adding, subtracting is always opposite sign, isn't it? So I just wanted to make that abundantly clear for you. Adding, subtracting is opposite sign. That's how you do the opposite. Dividing, you're already doing the opposite because you're dividing. You don't also make the sign opposite. You divide by the same sign. All right, so then that's just 5 and we're done. So there's the answer. Yeah, to answer the question about would the other order work, it will. It's just ugly. I'll show it. Let's do it. So 6x plus 10 is 40. You could divide first, but you've got to remember when you divide, you've got to do it according to truth. You can't just go like this and like this. That's not true. That's not just my opinion. That's just not true. Why? What do you mean it's not true, Mr. Aaron? Well, think about it. Think about if you had 12 plus 12, which is 24. Just take something that's simple and true that you know. And if you just divided by 6, just those two? That's not true. You're not taking the whole 24. Right? It's not just this guy. It's not just this guy that equals that guy. It's both these together that equal the 24. So you got to divide them both, right? Because whatever you do to one side is equal to the whole side, not just part of the side, right? Does that make sense logically? The more it can hit you on the sense level, I think you'll remember it way better. That's what I've noticed. If it's just steps I'm doing and it doesn't really make sense, it's just, in one ear, out the other. It's hard to remember, it's boring. But if it makes sense, like, oh yeah, that's true, then I think it'll stick with you better. See, that just wouldn't be right, to divide only part of it. It's the whole thing that equals the whole thing. So you got to divide the whole thing, and then that would be right? Because if you divide the whole, that'd be 2 plus 2 equals 4, which is still true, isn't it? But if you just divide a part of it, that's not true. So that's why up here, when you do the divide thing, to stay with the truth, you would have to divide all the left, all the right, because it's all the left that equals all the right. Now, that's going to be ugly. I'm just showing you another way to do this problem, which is an ugly way. We'd get to there, and then what would you do to finish? Now, I know you could simplify those fractions, but actually I'd rather not, because I'm about to subtract them. I'm going to leave them as they are. Subtract the 10/6 from both sides. So I did the dividing first. This is gone. This equals what? 46 minus 10/6? 36, better known as? Same answer. So really you can do whatever order you want, but this was easier, huh? Do the adding, subtracting first. Just easier. Any order is allowable, though, because we have an equation. Same thing to both sides, anytime you want. All right. So what do we got? 2x minus 5 is 9. There's a wall. Extend, I won't be alone. Try that one. Do the adding, subtracting first. Save the dividing for last. That's usually the easiest way to go. My voice doesn't fade into the Charlie Brown teacher this last half an hour, does it? The wah, 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 after 2 hours of talking at you. Is that how long it's been? What time did we get here? 10:30? It's 2.5 hours. All right, add 5 to both sides. 14, good. Last step to get x alone is divide. Divide by the identical twin, right? Same sign, same everything. Whatever's next to x, put that same exact thing under the bar, huh? Both sides, x is 7. Good? Questions on that? Is that really the answer that makes it true from the beginning? If x is 7, is it true?
Yeah.
2 times 7 is 14, take away 5, yeah. It's 9. That's what we're finding, huh? The value of x that makes it true from the beginning. By getting rid of everything with x to get x alone. All right. Okay, so minus 2x plus 9 is 33. There's the wall. Try that one. X and won't be alone. Remember when you divide, last step, divide by the identical twin. Same sign, same everything of what's next to x on your last step. First, subtract 9 from both sides, right? So first step to get x alone, subtract that 9, and these are gone, so minus 2x equals 24. Last step to get x alone is divide, and whenever you divide by the identical twin. Same sign, same everything, exactly what's next to x, which is different than adding, subtracting. Adding, subtracting is opposite sign, right? Okay, so then we get x is, now what's this? 1 negative is just negative, huh, when you're dividing? 2 negatives would be positive, 1 negative is just negative. Negative 12. All is well? Good? All right, problem, okay. Okay, so here we go. 4x plus 13x is 60. Here's the wall. Okay, now, 2x is on the same side. What do we do with 2x's on the same side? First time we've had 2x's. What we can do with them? Just add them, huh? Just like term them. Like terms, combine them together. 4x and 13x. 17x. Just combine them like that. Then x is saying I want to be alone. What do we do to get x alone here? Is that 17 added to the x, or is it right up next to the x multiplied? It's times, isn't it? It's right next to the x. So how do you get rid of something multiplied by the x? Going to divide, right? Everybody good? We're going to divide by the 17 there. Does that make sense? Instead of subtract 17? Is that good? Because it's multiplied. So get x alone, is that 4? Yeah, 4, huh? Is that good? Questions I can answer? We good? All right. Minus 4x minus 9 is minus 104. Try that one. So combine the like terms on the left side there. So what do those do? Yeah, because it's like money, losing $4, losing $9, losing $13, huh? Good so far? Now, x wants to be alone, so now, what do I do to get x alone here? Am I going to add 13?
No, you're not, I still have it.
Yeah, last step's divide, huh? Last step's divide. I got to divide, because that minus 13 is right up against the x. It's times the x, isn't it? So you got to divide. What are you going to divide by? Identical twin. Same sign. Same, what exactly is what's next to x? Put that under the bar, huh? Same sign, same everything. So we come on down. X is 2 negatives.
Positive.
Positive. Is it 8?
8.
8, thank you. Regular 8, positive 8. Good on that? We okay? Okay, so 8y minus 7 is 23 minus 2y. There's the wall. Equal sign, left side, right side. They're equal. So what do we do on this one? So the difference on this one from the last couple is we don't have like 2 x's on the same side or 2 y's on the same side. They're on opposite sides. So they can't, they can't just like 8 minus 2 is 6y. You know that, of course. Because they're on different sides of the wall, huh? So what do you do when you have the y's or x's or whatever on opposite sides of the equal sign? What do you do when they're on opposite sides? Basically, you get rid of one of them. So when you do the opposite of the lower y. It doesn't have to be the lower. You can do the higher. It doesn't really matter. To get rid of it. So you get rid of it. So you come up here and you say, okay, 8y and minus 2y. There's my. I'm not. By the way, don't even look at the numbers right now. Don't even worry about the negative 7 and the 23. They're not important right now. What matters is those 2 y's. You're looking at the 8y and the minus 2y, and you're thinking, okay, I got 2 of those. I got to get rid of the lower one. So the lower one's the minus 2y. How do I get rid of that? Add 2y, right? That's the opposite of minus 2y, isn't it? That's what I'm saying. Do the opposite of the lower one, of the lower y. But whatever you do to one side, you have no choice but do the same thing to the other, right? Got to keep the balance? Right, good? So add 2y to both sides. So that's gone, huh? So then what do we got here? 10y minus 7 is 23. Good. And now how do I get y alone? Add 7 to both sides. Now it's just back to normal. 10y is, what's that, 30. Last step is divide by the identical twin, divide by 10. So that y equals, what's that, 3? And we're done. Did that make sense then? So y is on opposite. No, we just did, like back here. I'll come back. But like right there, we had x's on the same side. Same side, just add them up like terms, no big deal. But when they're on opposite sides, you get rid of the lower one by doing the opposite of it, huh?
Common just to do the lower one.
Yeah, you don't have to. You can do the higher one. Like I could have subtracted 8y from both sides. That would work fine too. It really doesn't matter. So yeah, just get rid of one of them. Just do the opposite of somebody and do it on both sides. And then that one will go away and you'll just have one of them and then it's just normal from there. That makes sense? Opposite sides, do the opposite of somebody. Same side, just like terms, right? All right. I should have started with this section. This is the what we had to build up. This is the important section. 6x minus 10x plus, is that a 16 or an 18? 16, yeah. Okay, so there we go. Notice first off you have a couple x's on the same side. What are you going to do with the 6x minus 10x? Yeah, first do them. They're just add, subtract them, right? They're just on the same side. So they're just going to become minus 4x. Good? Good so far? Now you have x's on opposite sides. So just get rid of somebody. Do the opposite of one of them. It really doesn't matter which one. Whatever you do, do it to both sides to get rid of one of those x's. Okay, so what'd you guys do? Did you do the, you could do the opposite of the 4x. You could add 4x to both sides. That would get rid of that one. Or you could add 2x to both sides. That would, do you know what you guys did? Added 2x? I don't know. Both, I'll do both ways. How about? I'll do it again over here maybe. So I'm adding 4x to both sides. That gets rid of this one. And then, if I keep going from there, what is this? 6 plus 2x is 16. Just bring the 16 down. Right? Everybody see what happened there? Minus 2x plus 4x made plus 2x. 4 minus 2 is 2. And then what do you do from there to finish getting x alone? Subtract 6. So 2x is 10. Last step to get x alone, divide by 2. X is 5, right? Now, let me redo it. Because maybe you guys did it the other way, and that's fine. I just want to show you it's good either way. Maybe you guys added 2x to both sides. That's fine. If you added 2x, you get the same answer. This is gone. This would be 6 equals negative 2x plus 16. Right? This is the other way you could have done it. It worked just fine. So minus 4 plus 2 is negative 2x. Everybody good there? And then to keep going, you would say, okay, I got to get x alone, so subtract 16. Right? Try to get x alone, right? So I always go to wherever x is, whichever side x is on, and I get rid of all the stuff with x. You with me? Right? So if I'm doing it this way, yes, I'm doing this problem twice, right? I'm over here and I'm like, okay, here's x now, get rid of the 16. So then what do we get? We get minus 10 is minus 2x. Huh? Minus 10 is minus 2x. Last step is always divide. What do you divide by? Identical twin, exactly what's next to x. There it is. Two negatives, positive 5. Same answer, huh? Either way. It'll work either way. Positive 5. Does that make sense on that? Questions I can answer. So x is on the same side, like terms. X is on opposite sides. Do the opposite of somebody, like plus 4x or plus 2x. Getting rid of one of them. It doesn't really matter which one. Okay. One of my favorite Far Sides. Have you seen the Far Side one? Where the classroom scene, the teacher's up at the board doing something and the students are out there and one of the students raises his hand, who has a really, really, really tiny head, super shrunken head. He raises his hand and says, "I'm full. Can I go now?" Right? Are you feeling that? You're feeling, I'm just tired. I'm just tired of 3 hours of math here. All right, we're almost there. But this is an awful one. Five x plus 60 over 3 plus 8 over 3x. Okay, so here we go. Here's the equal sign. All right, bunch of ugly fractions. It's what they always do, right? You get the hang of something, then they go, all right, how about fractions now? And they just throw fractions into your mix. So we got a bunch of ugly fractions everywhere. Let's get rid of the fractions. That's the first thing to do. Let's just get them out of there. Before I do any of the other stuff about like terms or x alone or any of that, get rid of the fractions first. So let's do that. Let me write a note about how you do that, and then we'll do it. So first, get rid of fractions by multiplying by LCD the top of every term. Do that first. Before you do anything else, first get rid of the fractions by multiplying by the LCD at the top of every term. What am I talking about? What's the LCD? Well, there's only one denominator in this problem. It's not a trick. It's 3. It's just 3. What am I going to do with it? I'm going to multiply. Remember now, every term, right? Because equal treatment. We can't play favorites, right? The left side, all the terms on the left, equals the right side, all the terms on the right. So if I multiply everybody on the left, everybody on the right, even this 5x, which doesn't have fractions, I still got to do it. Equal treatment, right? If they were equal before, they'll be equal after if I treat them the same. All the terms on both sides. Good there? Now I call it, I said multiply the top. It's really just multiply. I'm just being clear that this 3 is over 1. Right? It's a whole number, so it's really in the top. Are we clear on that? Right? It's over 1. Whole numbers are over 1. They're in the top. Right? So what happens? They cross cancel. That's why we're doing it. We like that. We want to get rid of those denominators. We want to take them out. We're taking out denominators, right? Same thing here. 3 over 1. Bye-bye. No more denominator, huh? That's why we're doing it. We want that to happen. So what do we got? 7x plus 1x. Uh-oh, we got nothing. Hello. There we go. 7x plus 1x. That good so far? See how the 3's are gone? They've canceled. Right? No more fractions. What happens right here? 15x. 3 times 5, right? Plus what happens here? 3's cancel. 60. 3's cancel. 8x. We good? 2 there. Much nicer, right? No more fractions. Much nicer. No more fractions. So now it's just regular. Once you get those fractions out of there, it's just down to regular stuff. Is everybody okay with that step, though? Anything I can answer on that? No question? I feel like I'm begging you for questions. You guys don't have any questions? All good? Makes sense? All right, can you take it from there? So now just do regular stuff, you know. X is on the same side, like terms, you know, and then get rid of the x's on one side.
Will the least common denominator always be the same problem factor?
No. Yeah, so if we had like a denominator of 3 on one side and a denominator of 4 on the other, we'd use 12. Yeah, so you'd have to consider them both in that case. Yeah, we'll look at ones like that, maybe today, for sure tomorrow. So now combine the left side, 7x and x is 8x. The other side, 15x and 8x is 23x. We get to here. What do we do now with x's on opposite sides? So that was just like terms, right? X is on the same side, x is on the same side. But now what do we do with X is on opposite sides. We do the opposite of somebody. Doesn't matter which one. Just get rid of one of them, huh? Get rid of one of them. What would be easiest is to get rid of the 23x. Because then you'd have just x's on the left side. So I'm going to do that. I'm going to go minus 23x minus 23x. That'll clear that one out, huh? Does that make sense? Subtract 23x from both sides. So that's what we do, right? Everybody clear right there? X is on opposite sides. So I'll write it. X's opposite sides do the opposite of one of them. Right? So I did the opposite of this guy. Opposite of 23x. I could have done minus 8x on both sides. That'd be okay too. Maybe I'll show that. I don't know. You want to see everything in the world all the time. But anyway, minus, what's this, 15x? Yeah? And this is just 60, huh? Just bring down the 60. Like that. What's the last step to get x alone? Divide. By the identical twin, huh? By exactly what's in front of the x there. All right, and then what do we got? What is that? Was that negative 4? X is negative 4. And there we go. A lot of work on that one. Is that okay? So got those fractions, get them out of there. Multiply through. Common denominator, top, 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 all the way across. Good? I flash off of that? We good? Okay, so 5/2 x plus 1/4 x equals 11/4 plus x. Okay. So, what are you going to do first on this one? Yeah. So multiply through by the. Now, what is the LC? We got a 2 denominator and we got a 4 denominator. So what number do they go into commonly? 4. 4 itself, right? 2 goes into 4. So 4 itself is the common denominator, right? So go ahead and what are you gonna do? 4, 4, 4, 4. Everybody gets one, right? That's your first step. 4, 4, 4, 4. And then cross cancel. Multiply what's left over. Okay, so I'm going to multiply through by 4, by 4, by 4, and by 4. Here's the equals bar. So now cross cancel, right, guys? So in other words, 2 goes into 4 2 times. Does that make sense, what has happened there? 2 went into 4 2 times, and the leftovers multiply. What's left over? 2 times 5, 10x. Good. And then 4 cancels 4, 1x. 4 cancels 4, 11, 4x. Is that okay there? Does that make sense? That's the most important step. I think it's not too hard from there for you. But is everybody okay? Any questions I can answer on that first step? Does that make sense? Yeah, we cross cancel and multiply what's left over. Okay, take it from there. So 10x plus x. Those are just x's on the same side. So they just like term together, right? 10x plus x is 11x. So that's what we do with x's on the same side, just like terms, right? Now, what do we do with the fact that we have some x's on one side, some x's on the other? We get rid.
Subtract 4x.
Yeah, do the opposite of one of them, huh? It doesn't matter which one. You could subtract 4x from both sides, or you could subtract 11x from both sides, right? Either do the opposite of the 11x, which would be negative 11x, or the opposite of the 4x, which would be negative 4x, and do it to both sides, because you got to keep the balance. So I'm going to do the opposite of the 4x. That'll be a little easier. But the other way would be okay also. So that will give me 7x is 11. Does that make sense? And then last step, divide by 7. The answer is a fraction, 11/7. Questions on that? No questions? We good? How we doing? Oh, these problems are tough here at the end. 2.3. Using the principles together. Okay. Well, we are sneaking up on 1:30, aren't we? So we did the worst. We did that fraction one. That's good. Let's try this one. So 8x minus parentheses 6x plus 8 is negative 4. There's the wall. So try that one. That one won't be as bad. What do you do with a minus sign in front of parentheses? Yep, opposite, opposite. Eight x minus 6x minus 8. Good there, so it distributes, right? Like anything up against a floodgate, when the wall drops down, it hits both the things on the inside, doesn't it? Changing both signs. Minus sign changes the signs. When the walls come down, the minus goes in and changes all the signs. We get to there? And then, get it from there. 8x minus 6x. X is on the same side, like terms. Good to there. And now, x is saying, I want to be alone. So what do we do to get x alone? Add 8 to both sides. Like that. These are gone. And this is what, 4? 8 minus 4. Last step is always divide by the identical twin. So x is 2. Did you get that? Did you get that 2? All right.